Hey everybody, today we will do another quick video on L'Hopital's right? So has a little bathtub here, and of course right, um so we'll do two different problems, right? So the first one is the following. The first one, we have the limit the limit limit, all right, as x approaches 9, right? And we have the square root on top, the square root of x. Okay, so on the bottom we have 2x squared, and I believe it's minus 17x minus 17x minus 9, I believe. Yes. Okay, so what did we do first? All right, so actually this is a minus 3 here. What we do first? We try. Okay, so when you get this problem like this, it will say evaluate, right? And this is horrible, but right, so evaluate, right? It will say something like this. It will say evaluate whatever, right? Evaluate the limit. Evaluate the limit. I will say that, something like that. The problem will be stated. Okay, so now with direct substitution, and we get, right, so we get the square root of 9, right, minus 3 over what? Over 2 times 9 squared minus 17 times 9 minus 9, right? So now we evaluate this, right? As x approaches 9, right? In other words, x a represent 9, right? So as x approaches a, right? In this case. But anyway, I'm just kind of just do like a little bit of review of what we did last time, but that's not a big deal. Okay, so let's take that, the top, which is what? So that is 9, the square root of 9 is 3, all right? And you know that we get a 0 on the top, so we check the bottom, right? So we check the bottom, and this is 9. 9 squared is 81, right? But then 9 squared is 81. But then when we do that, right, 9 squared is 81, then we end up with something, right, like this. So 9 squared is 81, right? If we take the derivative, well, first we evaluate, right? And we notice that it will be, in this case, so 9 squared, okay, so let's do it. Okay, let's do it. Let's do it. Okay, so this is 81, right? So 81, the bottom line is this will be equal, okay, so this is 150, this is 153, but hold on a second, let's see. So alright, so actually the bottom, the top, right? So if we do this in the bottom, right? So 81, so over here we got 81, right? And then 81 minus, okay, so 81, right, times 2, right? So we got 2, okay, 2, and then we got 16, so it's 162, right? 162. I just want to make sure that we're doing this right. So this guy right here is 162, right? Now, this guy right here, just do it real quick. So 17 times 9, right? Okay, so 17 times 9. So 7, right, is 63, so it takes, write down the 3, carry the 6, right? Carry the 6. Now, okay, so carry the 6 because it's 7, right? So now, this is 63, so carry the 6, and then we got 9, right? So 9 and plus 6, 153. 153. Right. So now we got a 153 negative here. Making sure that we doing the math first. Making sure that this work either works or doesn't work by direct substitution. Alright. Now, this guy right here, right, so this guy right here, right, we know this 162, right? And then we got minus 163, right, 153, 153. Right, and then we got plus 9, right? Minus 9, right? Minus 9, right? So now, you take that 9 and you add it to this, right? So you add it to this is equal to 12. You carry the 1, right? Carry the 1, you get added to this. It's actually 162, right? So now, 3 minus 3 over 162 minus 162 is equal to 0 over 0. Again, this problem is not made purposely, so we have to do L'Hopital's. Okay, so let's do derivative, the stuff that I like, right? Because this stuff is, this stuff is it's math, but it's not analytical. I like analyzing stuff, right? That's what I like. Okay. But anyway, so we have to do the process of. Okay, so now look at this problem. Let's look at this problem right here. And let's take the derivative of top and bottom, right? So, in order to take the derivative this, we have to transform this guy to a different type of the same function, but we want to make sure that we have exponents on it. Right now it's under the square root, it's under the radical, so we don't have exponent. So now we're going to make it like this. So x to the 1/2, right? Minus 3 over 2x squared minus 17x minus 9. Now we can take the derivative of this. We know the derivative of this is 0. The derivative of this is 0. The derivative of this, we take it, this half, we take it to the front, and we got a 1/2. Then this is the tricky, and this is the part that I like about analyzing this. We cannot violate the rules of calculus, right? So the derivative says that we have to take the exponent minus 1. Okay? So we already brought the exponent to the front. Now, we take the x. The derivative of this is 0, so forget about it. Now, what we do is the following. So we do 1/2 minus 1. Okay. And the bottom over here is easy. Actually, easy. We take this and do make it the derivative of what? It's going to be 4x minus 17. The derivative of the top of this is a little tricky because I have to find the common denominator of this, which is what? So it's 1/2 x to the 1/2. Common denominator is 2, so I got a 1/2, and that becomes this and this, right? Now, the bottom is still the same, 4x minus 17, basic cake. The bottom is basic cake. The top, I have to work a little bit, right? So the top, I got a 1/2 x, right? That is a negative half on the top over 4x minus 17. This is good, but it's in the proper form of writing it. If you want to substitute this and stuff like this, it's going to make things harder. So what we want to put it in the bottom. Right, we want to write it in the form that it's supposed to be. Like, okay, so I think you guys remember when you got something like this, right? So you got a to the something, right? So a to the negative 1 becomes 1 over a, right? Hopefully you guys remember something like that from basic algebra, right? So again, we playing with, even in calculus, we're dealing with basic algebra, right? You got this little toolbox from little tools, right? In your toolbox from basic algebra, you pull that out and you use it over here in calculus. Okay. So if a to the negative 1 is equal to 1 over a, then this is similar, right? I get a negative 1/2 on the top. So what I do is I change the function, bringing this to the bottom, So what I do, I bring this to the bottom. Right now, it's like this, right? It is kind of confusing because it's kind of, it's kind of hard to write this, but this is sitting in front here. This is not underneath right now, but I will put it underneath. I will bring this down and keep the 1 on the top, right? So it's going to be like this. So this is nothing but something like this, right? So okay, bring this down, and this is 1 over what? 1 over 2 times the square root again of x, right? and then 4x minus 17. And somebody can say, well, why do you bother in doing this stuff so complicated? Bring in a one, make it a square root again. Well, A, this is more in the standard form. B, to do the mathematics, this would be easy than this. And you will see it right now. Okay, so now, and remember, we have the limit as x approaches 9. Okay. Let's bring this guy over here. So we have what? We have 1 over 2 square root of x over 4x minus 17. Okay, so now we do this and we get what? Now this is equal to 9. So 1 over 2 times 9, the square root of 9, over 4 times 9 minus 17. Now, to take the square root, see, that's what I'm saying. This now is easy because all you got to do right now is substitute, and then you take the square root of 9 is 3, and this is equal to 1 over, okay, so it's going to be step by step, 2 times 3, right? The square root of 9 is 3, 2 times 3, and then I got 36 minus 17. Okay. Okay, so now I got this, and the top is going to be 1 over 6 1 over 6, and the bottom is going to be this, all right? So take this from that, and borrow 1 is 16, right? Borrow 1 to this is 16, and then, of course, it's going to be 19, right? 19 like this. So 1 over 6 over 19. Okay. Now, 1 over 6. 1 over 6, right? 1 over 6 over 19. But remember that this 19 is also over 1. This is a number, right? And any number, you assuming this over 1. Now you flip this, right? You flip it. Now, you flip this. When you flip this, right, you get the following. You get 1 over 6. Basically, what you're saying is 1/6 divided by 19. But you flip this. When you flip it, because it's over 1, then you multiply. Right? Flip, multiply, and then you get what? You get 1 over 19, which is, this is 14, right? Carry 1, and then this, okay, so this is 14, right? Carry 1, and then you multiply this time. This is 6, and you had a 14, right? You had a 14, and this, and then 6, it technically is 1 over what? 114. Now you see that it requires a little basic mathematics, going back to the, I guess, high school levels and all that. Or maybe stuff like this. Maybe this type of operations, maybe, I don't know, maybe ninth grade math, or 8th grade, something like basic. But I guess depending what school you go to, I mean, I don't know. It's weird. I mean, nowadays some schools aren't teaching anything, so it's kind of discouraging, but it's the truth. Okay, but anyway, so now that is the answer, right? So now step by step. Okay, so now we will do another basic problem, and this problem has to do with it's going to be it says the following. Actually, I don't know if I want to write this, but actually says that in exercise 11 to 16, it says in exercise, right? They have abbreviation? No. In exercise, yeah, in exercises, 11 to 16, right? It says apply the L'Hopital's rule if, keyword, if applicable. Right? So basically, analyze, that's what it's saying. Analyze, if it's applicable, then if applicable, then just do it. Limit to the limit to the limit x approaches plus or minus infinity. Now again, those guys that don't believe, in God, and they believe that, they know it all, you can try to do this math and see what does it work, right? If you can actually calculate something goes to infinity large or infinity small, try to do it. And again, you can analyze it and try to make some sense out of it, but you cannot calculate to infinity because only God knows the infinity. Because He is the infinity of the infinities, right? But we can analyze the problem, right? We don't have to calculate, or infinity and all that. I mean, it's honestly, for the human being, it's undefined. Infinity is just a word that mathematicians try to kind of, just put it over there, but you can do some proofs, but doesn't mean that you can calculate anything that goes to infinity, right? But anyway, I'm not going to argue this because it's basically here, okay? But we can analyze it, right? Okay, so now let's do a problem. Okay, so let's do a problem. Okay, so let's do 3x minus 1 over 7 over 7 minus 12x. Look how simple this stuff, right? Very simple. So x goes to infinity plus or minus infinity. infinity large or infinity small. Okay, so this is the tricky part that I need to, like I said, we need to analyze this. Look at this. I got a 7 and I got a 1. Think about it. If I substitute 3 times infinity minus 1, it doesn't make any difference. If I have a 3 millions, okay, let me put it as an example. Let's say that Bill Gates loses $1, or Elon Musk lose $1. Now that Elon Musk bought Twisted Twitter, and they call it X now, right? Matter of fact, I reopened my account right now, which was Twisted Twitter. I kind of reopened it, after, Elon Musk is kind of, I don't know, but do you think that if Elon Musk loses $1, after multiplying 3 times a million, he will care about the dollar? Do you think? I don't think so. I think he lost more already after he got Twisted Twitter, right? He lost more. I think he lost already more than $1. But I don't think Elon Musk cares about it too much. Do you think? Okay, now another question. Do you think if you multiply 12 times a million and it's negative and Elon Musk is losing 12 million and you say, hey Elon Musk, sorry man, you're losing money. Here you go, $7. Do you think that Elon Musk cares about the $7 you give him? Think about it. He already lost $12 million. He's not gonna care. He's not gonna care about $7. I mean, what? Elon Musk is going to say, hey, thank you, man. Thank you for the $7, right? And I'm sorry, I didn't put Bill Gates as an example, but because, I don't know. I don't know why, but same thing. So this is the example, right? So now okay. So if Elon Musk don't care about this, Elon Musk don't care about this, then it's irrelevant. It's irrelevant. These numbers are irrelevant. As x approaches infinity, actually, in this case, it is a positive infinity, but it's still doesn't matter. So it's positive infinity. So Elon Musk don't care about this, so we cross them over. Don't care. Now we take these numbers in infinity 3 times. And then we put infinity. And then we put minus 12 infinity. Now what? What the heck? What is going on here? So you have infinity multiplying infinity, and that is infinity. So now you can cancel the infinities out because you don't care about the infinity either. You got infinity or infinity, but you have a number in front of it. If you have just infinity or infinitive, not good. But you have a number over here, you can cancel the infinities, and you got what? You got 3 over negative 12 over 12, which you can write it as, right? 312 negative. Okay, now take the top, divided by 3, you get 1, right? 3 divided by 3, you get what? 1, right? And then 12 divided by 3 is equal to what? That is equal to 1 on the top, and it's a negative, of course. 12 divided by 3 is 4. Put a sign over there, and then put a fourth. And that is the answer. So yes. So that is the 2 problems that we had in an application of L'Hopital's rule on both of them. And remember, this is the this is a Christian Academy now, engineering. So Christian Engineering Academy. Remember, over here we learn something every day because Jesus is good. Thank you for watching. I'll see you in the next video.